This is question 3 from section 2.1, the tangent and velocity problem in Stewart's 7th edition calculus book. Question 3 says, if point P, 2, the point 2, negative 1, lies on the curve y equals 1 over 1 minus x, then calculate the slope of the secant line for the following values, parts 1 through 8. So you're given these values for parts 1 through 8, which are x values, which you can set up in a table here, parts 1 through 4 given in blue here, and parts 5 through 8 given in red down here. So you're given these x values, and to find the corresponding y values, you would just plug the x values in for x in the equation of the curve, which is also demonstrated by point Q, which is what your table is. You have your x coordinate for your x coordinate, and your y coordinate is the function of the curve. So after calculating your x and y values, which I've already done in these tables, to calculate the slope, you'll have your py coordinate minus your qy coordinate over your px coordinate minus your qx coordinate, which for the first value here, the first ordered pair, is negative 1 minus negative 2 over 2 minus 1.5, gives you a slope of 2. And that's part 1. Part 2, you have 1.9 for your x value, negative 1.1 repeating for your y value. Y values on top, x values on the bottom, p, q, p, q, and your slope comes out to 1. And for part 3, your ordered pair slightly changes right here, but you are also given a slope of 1. Part 4, again, your q values, your qy and your qx values change, but your slope is still 1. And for parts 5 through 8, you're using these ordered pairs here. And for the first one, you have the ordered pair 2.5 as your x coordinate and negative 0.6 as your y coordinate for your point Q, and you have your x coordinate for P and your y coordinate for P, and calculating that gives you a slope of 0.8. For part 6, the method is the same. Your slope comes out to 1. And the same things for part 7 and 8. Your ordered pairs change that you're using, but the method is the same, and your slope comes out to 1. So part B is asking, using the results of part A, guess the value of the slope. And one thing you can recognize is that for the table in the blue, you're approaching the value of 2 for your x coordinate from the left, which means below 2. And your slope, as you can see, as these x values get closer to 2, the slope you're calculating in part A becomes 1. So you're approaching a slope of 1 for the tangent line as you approach 2 from below. And in the red, you can see you're approaching 2 from the right, or values above 2 for this table in the red. That's part A 5 through 8, and you're approaching from the other side of 2, and you still get a value of 1 for the slope of the tangent line. So from the slopes of the secant lines in part A, the slope of the tangent line at point, this should be point 2, -1, appears to be approaching a value of 1. And part C is asking to then find the equation of the tangent line at the point 2, -1. So you have your slope as 1. It's what you found in part A. So the tangent line is approaching a slope of 1. You have your point P, which is 2, -1, and the equation of a line is y equals mx plus b. And to find the equation of a line, you use this equation here, y minus y1 equals m times the quantity of x minus x1. Now plugging in your x and y coordinate pair at point P for y1, y1 would be this -1, and m is 1, and your x1 will be the x coordinate of P, which is 2. So you'll have y minus -1 equals 1 times the quantity x minus 2. And that simplifies down to y equals x minus 3 is the equation of the tangent line at point 2, -1.